Hello, we'll be seeing the third scheduling algorithm in CPU scheduling, that is priority scheduling algorithm. In priority scheduling algorithm, in shortest job first and first come first serve, we saw the burst time. Whichever had a shortest burst time, we gave the CPU to that in shortest job first. In first come first serve, whichever the process arrived to the ready queue first, we gave that process the opportunity to use the CPU first. In this, we will be checking something called priority. Priority is a very main thing in priority queue scheduling. We'll be giving a column called priority, where based on that you will be giving a process to the CPU, and whenever a process with equal priority comes in the ready queue, we'll be using your first come first serve to break the chain. When we do the problem, you'll understand what is priority and also how do we break by using your FCFS in the problem when we're doing. Your priority queue scheduling is divided into two types, that is preemptive scheduling and non-preemptive scheduling. We already know what is preemptive and non-preemptive. If you don't know what is preemptive and non-preemptive, please check the previous videos. We'll start with the problem for preemptive scheduling algorithm. We've taken an example here for priority scheduling. We'll be doing non-preemptive priority queue scheduling and we'll be doing the problem. For this, we have to draw the Gantt chart first, and we have to find average turnaround time and average waiting time. Now, if you see the problem that is given here, we have 7 processes. We also have a column called priority that is added, and also we have arrival time and burst time. Now, this column is called as your priority column. Priority, the number that is given, right? You will be considering the priority according to the number. In the question, when they're mentioning, they'll give a question whether the priority is higher the number, higher the priority, or else they also will give lower the priority, lower the number. They might give higher the number, higher the priority, or else they'll mention lower the number, lower the number, higher the priority. That means higher the number, higher the priority. Now if you see which is the highest number here, 10 is the highest number, so whichever has the highest number here will have the highest priority. So 10 will have the first priority, 7 will have the second priority, 5 will have the third priority, third 6 will have third priority, 5 will have fourth priority, like this. Higher the number, higher the priority. Now when we talk same thing about lower the number, lower the priority, we'll be considering the lower the number whichever is the lower as the highest priority. That means first here 2 is the lessest number or the lower number in the entire priority, so 2 will have first priority, 3 will have the second priority, 4 will have the next priority, 5, 6, 7 and 10. So this is how we will be considering higher the number, higher the priority, or else we also will be considering lower the number, lower the priority. This will be the part of the question. They will mention whether it's a higher the number, higher the priority, or lower the number, lower the priority. In case if they don't mention, you can directly go with 2, 3, 4, 5, 6 and 7 and 10. That means lower the number, lower the priority you can consider, or else you can check for the question. They would have given higher the number, higher the priority, or lower the number, lower the priority in the question. Now I hope you have understood. Now in this program or in this problem that we are doing, we are giving lower the number, lower the priority. We'll start with the problem now. So before we draw a Gantt chart, I'm trying to use a ready queue, because when you have a ready queue, you know which process will go next and it is easy for you to understand. Now we have to check the arrival time. Here we are not checking the burst time, because we will be only checking arrival time and priority. We'll be comparing only between two of this. Now during 0th time, there is a process called P1 that has come, which has a priority of 2. Now there is no other process that has come into the ready queue, so I'll be directly giving P1 to the CPU. I'll draw the chart here. And this is non-preemptive scheduling. That means once a process goes inside the CPU, it completes the task and comes out. No matter which process comes inside the ready queue later, you are not bothered, but you're completing the task. Now P1 has a Now P1 has a burst time of how much? P1 has a burst time of 3. So I'll start with 0 and I complete at 3. Now during, there is 1 millisecond and there is 2 millisecond in between, right? So during 1 millisecond there is a process called P3 that came into the ready queue, and during 2 millisecond there is a process called P2 that has come, and during 3 millisecond there is no process that came into picture. Now if you see, this has a P1 has a priority called 3, sorry, P1 has a priority called 2, P3 has 3 and P2 has 6. That means lower the priority, higher the lower the number, higher the priority. So 2 is already completed. Now we have P3 and P2. So P3 and P2, if you see which is having the lower number here, P3, that means P3 will be giving the higher priority. We'll give the CPU to P3. P2 will be here in the ready queue. P3 enters the CPU. We have to also check the burst time of P3. We have 4 millisecond. Now 4 milliseconds, since it is non-preemptive, it completes the task. So it will take for 7 millisecond. Now I have to see who has come in this interval. During 4, 5 and 6 millisecond, I have to check who has arrived. During 4th millisecond, I have P4 that has arrived. During 5th millisecond, I have P6 that has arrived, and during P7, I have there is P5 that has arrived during 6th millisecond, and also there is P7 that arrived. Now during P3 we have 4, 5, 6, 7 milliseconds that has completed by P3. If you see, there is P2, P4, P5, P6, everything has arrived, right? Now all the processes arrived and P3 already completed the task. Now in P2, P4, P6 and P5 we have to check the priority. So P2 had a priority called 6. I'll write the priority here. P4 had a priority that is 5. P6 had a priority that is 4. P5 had a priority 7. P7 had 10, right? Now in this, lower the number, higher the priority. Which is having the lowest priority? P6 has the lowest priority. So I'll be giving the CPU to P6 now. P6 will go, P2 remains, P4 remains, P5 remains, and P7 remains. Now if you see, all the process has arrived, so you don't have to look for any other process. You can start with your problems. P6 has a burst time of how much? 4. So 7 plus 4 is 11. Now P6 is done. Now again we have to give some P2 is 6, P4 is 5, P5 is 7 and P7 is 10. So which is having the least priority here? We have P4 that has 5. So P4 will go next. P2, P5 and P7 remains as it is. So P4 will go. P4 has a burst time of how much? 2. So 11 plus 2 would be 13. P4 has completed the task. Now we have to see which one will be going. So 5 is done. The next process, that is 6. 6, 7 and 10. So we'll be giving P2 next. P5 remains as it is and P7 here. So P2 will go here. Now P2 has a burst time of 5. So 13 plus 5 would be 18. P2 is completed. Now P5 and P7 is left. In P5 and P7, P5 has a lower number, higher the priority. P7 remains as it is. P5, the burst time of P5 is 9. So 18 plus 9 would be 27. And the last process that is left is P7. So P7 has a burst time of 10. So 27 plus 10 would be 37. So this is the Gantt chart that you will be getting. I'll erase this part so that you won't get confused. Now this is the final Gantt chart of priority non-preemptive scheduling. Now Gantt chart is done. We have to calculate completion time. We have to calculate completion time, then later turnaround time and waiting time, average turnaround time and average waiting time. So for completion time, we have to see when is the process completely completed the task. So P1 has completed during 3. So completion time will be 3. P2 18. P3 completed at 7. P4 completed at 13. P5 completed at 27. P6 at 11. P7 at 30. 7. So this is the total completion time. And turnaround time, the formula is CT minus arrival time. So 3 minus 0 is 3, 18 minus 2 is 16, 7 minus 1 is 6, 13 minus 4 will be 9, 27 minus 6 is 21, 11 minus 5 is 6, 37 minus 7 will be 30. So this is the total turnaround time, and waiting time will be 0. The next one will be 11. This will be 7. This will be 2, 7, 2, 2 and 30. So this is the waiting time and turnaround time. Now turnaround time is, we have to calculate the average turnaround time. So 3 plus 16 plus 6 plus 9 plus 21 plus 6 plus 30 divided by, what is the number of process? 7 process. So divided by 7, the answer will be 91 divided by 7, and 13 millisecond is the final answer. For waiting time, you have to add 0 plus 11 plus 2 plus 7 plus 12 plus 2 plus 30 divided by 7. The answer will be 7.71 millisecond. So this is the final answer for your priority scheduling non-preemptive.